All right, what is crack-a-lackin', my little mathematicians? So what we are focusing on today is how to use trig in an equilateral triangle. Okay, that's how we say this lovely word. Equilateral, equi means equal, lateral, honestly, I don't know. Side, length, question mark, maybe, whatever. Equilateral, equal sides, everything is equal. So boom, 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 those three sides are equal. Same thing for all of our angles, okay? In an equilateral triangle, we know that these three angles, let's all call them angle x, x plus x plus x need to add up to 180, right? Because all angles in a triangle add up to 180. So that would give me 3x equals 180, x equals 60. And again, this is obviously going to be true for every single triangle. Equilateral triangle, let me catch myself there. The angles are always going to be equal to 60 degrees in an equilateral triangle. All right, so that's what we were just figuring out right there. The measure of angles CAB. CAB, 60. CBA. CBA is 60. Same thing for angle ACB, right? Like I said, all 60 degrees. Now, we're going to take that triangle and cut it in half. All right, we're taking it and just folding that loveliness in half. Okay, so we have that these two sides are still equal. And then this right here, that CD, that gray line, is actually cutting this whole segment in half. But remember, AB is still congruent. Oops, that's the wrong symbol. Is still congruent to AC, which is congruent to BC, right? So these three big sides are all equal. So now we're going to be looking at our angles. Remember, our angles, let me write this in, we're all 60 degrees. Okay, so CAB is 60. CBA is going to be 60 again. Now this is where things get a little difficult. This right here, this beautiful line bisects this original angle. So this was originally 60. We are cutting it into two equal parts. So that's going to make each of them 30 degrees, right? Each of these are 30 degrees. Okay, so A, C, D is going to be 30 degrees. Lastly, A, D, C, right here, we dropped this line in. And this was perpendicular. These two lines are going to be perpendicular. So that's going to be 90 degrees. Right? So we got 30, 60, 90 degrees that we're working with. Right? So I'm going to go through one example to find a bunch of different lengths using Pythagorean theorem and some trig. All right? So we are given this triangle. We know all of these fun things about it that we just went over. All right? If AD is 7, all right, so let's just start labeling. Whew, I'm about to sneeze. Excuse me. Sorry, guys. It is spring, and my allergies, y'all know, are acting a fool. So that's why I am so sniffly. I'm sorry. Okay, I'm so sorry. But yeah, that's why, that's what's up. All right, so let's start labeling. We know this side and this side are equal. And these two little pieces are equal. All right, so AD, if AD is 7, that means this next segment is also 7. But remember, this whole piece, AB, add them together, 7 plus 7 gives me 14. What do we know about an equilateral triangle? All three sides are congruent. So these two sides are also going to be 14. All right? That's how we would do that one. So that's some of our sides. So let's see. AB right there is 14. AC is 14. CD, okay? Two ways that we could do this, right? CD right here in the middle, I'm going to label it as X. First way we could do it, good old Pythag, all right? Love the Pythagorean theorem. Love me some old Greek math, right? We have 7x 14. Okay, we know that 7 squared plus x squared equals 14 squared. Please do this in Desmos. 7 squared is 49. 14 squared is 196. So 49 plus x squared equals 146. Was that it? 196. That didn't seem right. Yeah, 196. Subtract that 49 from both sides. So minus 49. We get what? X squared equals 147. And then how do we undo squaring something? Oh, that's going to be the square root, y'all. Shocker. We square root both sides. All right. Come back to Desmos. SQRT. 147. That gives us 12.1. All right. X is approximately 12.1. All right. That's one way to do it. Pythagorean theorem. Second way that we can do it would be with trig. Okay, so let me redraw our triangle again and be sure to include our angle measures. Let's see, we had ACD. This is unknown. That's 60 degrees. Oh, that was 90 degrees. That's 60. That is 30. We knew this was 7. And then this one right here was 14. Okay. It does not matter if you use the 30 or the 60. You can use whatever trig function you want. We got so, ka, toa. Okay, as long as you are including that x in there. All right. I am personally, for absolutely no reason at all, a big sine fan. So I'm going to use sine. All right, and I'm going to use this 60 degrees. So this x is the opposite. 7 is adjacent. 14 is the hypotenuse. So sine of 60 equals opposite over hypotenuse. How do we undo dividing by 14? We're going to multiply by 14 on both sides. So then we get 14 sine 60 equals x. That's exactly what you are going to type into Desmos. All right, go back to Desmos. Let me clear out all this mess I have. 14 sine 60. Oh, shocker. We got that x is approximately 12.1. Again. All right, so it doesn't matter which way you do it. For this one, I feel like trig might be easier. I don't know. I kind of go back and forth on whichever one I would do. But really do whatever one you feel most comfortable with. All right.